Works. We are. You get me to check. That's the right word. Yeah, well done. I want to make this very clear that we are going to be using those same skills that you've already been developing. And I think on the whole, you're all pretty good at it, right? Or know what I mean by the end term of a pattern. Yeah, we had that game of shoot at the end, didn't we? Pretty much a strength for a lot of people, which was great. We are going to be looking at something called functions, and this is because as we move on in your mathematical careers, we tend to talk about functions rather than number patterns. So we've kind of talked number patterns because that's the introduction to it, but in future we talk about functions. Do you remember what the unit is called? What it's about, sorry, wrong. What's the whole unit? It's not, that's only part of it actually.
Understand the language.
That's yeah, go on. I'm sorry. Go on, say it. Okay, so that was the one part, but the main bit I want is the language of mathematics, which is algebra. Okay, so what we're learning how to do is write mathematics using algebra. So you've made a great start to it, and really there's not an awful lot to algebra. The ability to work with it and manipulate it, it's where it gets harder and harder. But the general idea behind it is describing the link between two numbers. That's all it ever really is. Okay, so we can substitute in, which we've done, right? Anyone give me an example of substituting into an expression? Okay.
If it was like 2 plus x, and then it said x equals 3, it would be 2 plus 3, and then so
Yeah. So if it was 2 plus x, that would be called an algebraic expression. Good. Someone said the word term as well. That's part of it as well. And we substitute a value into the letter, don't we? Because the letter represents a number that we haven't decided yet. So we've done our substitute. So functions is actually just another way of thinking about the same thing. Right? It enables us to go a little bit further. Yes. Yeah. Once we're ready. Yeah. Okay. So, who would like to share? I think go for it.
What we did.
Your the sequence. 5, 11, 17, 23, 29. I think we can stop there. And I'm going to ask someone else to tell me what the nth term for that is. Okay, is that what you got? Yeah. Zoe? Okay, are we all looking at these, confirming? And Austin? UN equals. Sorry, add 1. Alright, so we've got 2 lots of 6. Helen?
We put 7, 16, 25, 34.
7, 16, sorry.
25,
25,
34,
34,
40.
43. Okay. There's 2. Okay. One more then, okay, go for it. Number 7, okay.
12, 17, 22, 27.
Stop there. Round. Five n plus 2, yeah. What you gave me there was, I know you did it on purpose. What you did was intentionally left the n out, and the trouble with that is then it just becomes un is always 5 plus 2, which is just 7, right? So, before I ask you what the word is, let me ask you, can I get all of you to write down 2 of those that we've just done for us? Just 2. You pick. Pick the top 2, first and third, whatever you like. You've done what? Okay. Should we have a look at the first one? Let me just ask you, by the way, what does me writing down U12 equals, what am I asking you for? Do you want? Yeah. The 12th term, perfect. Yeah. I thought he was going to say the 12th number in sequence, but 12th term, awesome. All right, I'm after the 12th term in this sequence. All right, so how do we do it? So we've got n has to equal 12, so we do 6 times 12 minus 1. 6 times 12 is? 72. 72 minus 1 equals 71. Okay, Zoe. So 6 times 34. I'm not saying you're wrong, saying it the other way. I'm just keeping it consistent with the 6 times n. Yeah, it's fine doing it the other way. 6 times 34 plus 1 is 205. 6 times 34 is 204 plus 1 makes 205. Who's going to do U6 for me? A nice easy one. Kaylin? Yeah. 52. Riley? 5 times 50 plus 2. 250 plus 2 is 252. Good. All right. Just what you've just done there, by the way, is called. We already talked about it. Not yet. You have just substituted into a function. Good. Someone used it. Yeah. Good stuff. All right. Now, I can redraw this. So here's something for you to draw. All right. Got another page. Let's talk function machines. Okay. I'm going to do this, and then I've got something online for you to do on Teams. So, okay, function machines, and we are going. I'm just going to give you the vocabulary. I'm not going to talk a lot about it. I'm hoping you'll be able to use the stuff I've just been doing, and what it is online, and develop your understanding. So, function machines, basically, what they call it is a beginner's way of saying, okay, here's a machine. It has a function in it. A function is just another way of saying, this is what you need to do to the number. Okay? Yeah, we can write both. Right? So a function machine, a function is what do I do to the number? Now, what we say is, we put a number into the function machine. The number going in is called an input. And what comes out is, and I'll give you an example. So for instance, I can put 3 into my function, okay? And what comes out is a 6. Okay. Now, those two numbers are just like me putting n is 3 in and u3 being 6. Right? But what we don't know at the moment is what is that expression in the middle. That expression is now called a function. But it's the same idea. Does anyone have any idea what it could be? So this could be considered the n, and this could be considered the number in sequence, but what I'm now looking for is, could anyone think of, maybe if I explain it a little bit better. So, for instance, if we have un equals 2n plus 3, okay, that could be my function, 2n plus 3. And what goes in, I could say n equals 2. What comes out? 2 times 2 is 4. 4 plus 3 is 7. Make sense? So we times it by 2. Now this is considered a 2-part function. 2 parts to it. Any ideas what this could be? Could be a times 2. Could be a plus 3. Which one is it? Could be both. Which one am I thinking of? I'm just going to say no to whatever you say, because I mean like that. What you would need to say is, Mr. Potts, we don't know. We need another piece of information. Another piece of information. And you might say, Mr. Potts, just do me a favour. Can you stick another input in so I can see what's happening? Of course. I'm going to put 4 in. Okay? And I'm going to tell you what comes out is 7. So now you have 2 pieces of information and we know it must be plus 3. Okay? So that's how we can find the function. We can also do exactly what we were doing before. Okay? Anyway, that's all I kind of want to say. I don't want to give you too much. I want to see whether you can develop your understanding yourself. How do you feel about what we've just done there? It's just called function. Might need a bit more practice. So let me, I can put it back just so that people can get on. On your laptops, there's something called Function Machine Math Playground. When you open it, what you have here, don't we all pay attention? No, you really aren't. All right. Where is it? Did I skip it? Oh, it's there. Okay. Beginner, advanced. You can see. Beginner just says all you have to do is find the times by. We'll start with that. Then it looks more like the expressions that we've learned before. So if you have a look at beginner, what you have basically is, here's what the function machine looks like. You are asked, you can either tell it what input you want to put in, or you can just get the computer to do it for you. So if I click computer percentage, it's telling me, and the numbers are quite big, 46 goes in. So you would need what? Another piece of information. Now, if I went computer decides it also goes in. Now, you've got to try and decide, how do I get from that input to that output? You think it's a times 8? Times 8, click down. Oh no. Did it? Excellent, you did it. Hooray! Yeah.
You get. Oh.
I think you had some good. Use this number of his timetables. Now, I would suggest if you look at those numbers and think, I have no idea, you might actually want to decide the input yourself. I think that makes it super easy. Anyway, you got the idea? Go to the pattern. How? Take me through the steps for finding 6n minus 1.
Is 5.
Okay.
And then my answer is 6. 5. And then the numbers are that one would be because usually it's 6, 12.
Okay. All right. All paying attention. So, what Riley just said was, really, she said 11 minus 5. So what we're doing is we are figuring out the difference, the plus 6, yeah? And to do that, we really need numbers that are next to each other in the pattern. Anyone know the word next to each other? So that begins with C. Content? No.
Close.
Consecutive.
Oh.
Not a problem. I will expect you to know that at some point. So if we can know consecutive numbers in the pattern, we can work out the plus 6 bit. Now, if it was a function machine, 5 would be the output. What would be the input? 1.
Yeah.
What would be the input for 11?
2.
2. 3.
4.
What did we call it before? We n equals. But if we did function machines, okay, in my input, if I put a 1 in and got a 5 out, and then, what I need to know is, what does it add up next? What would be the next number? So what do I choose as my next input?
2.
2. And it would get 11 in one, which is working out. And then I'm like, I know it goes up in, so I know it must be times 6 first, right? Because it would be 6n, and what does that mean? We times 6, and then, because it's 5, we know it's. So that will make your number machine game super easy, because what I noticed, people were just chucking any numbers in. I've just made it super easy, because what are your input and output always going to be now? 1 and 2. Makes it easy, right? Yeah.
What if, like, when you put it in, it had smaller number?
So, what if I put a 1 in and got a negative 7 out? And then I put a 2 in and got a negative 5 out. Doesn't change the maths. Plus 2, good. So it would be 2n still, minus 9. How would it look like in this game? It would be times 2 minus 9. Go for it. Last couple of minutes. See if that helps you rattle through. You can probably go up a few levels now.